let's go ahead and get started. Last time, we were in section 3.1, and I still just want to kind of go over this with you one more time, because these are very important. This was section 3.1. We focused on the product rule and the quotient rule. And the product rule, when taking the derivative, y prime, or if you want to, your dy over dx, is equal to f prime of x times g of x plus f of x times g prime of x. Now what I try to get you guys to do is memorize the words. Formula's nice, but the words help you so much more. It is the derivative of the first times the second plus the first times the second. That alternating derivative thing. That is the product rule. The quotient rule, when you got y equals f of x divided by g of x, then your derivative y prime, or your Leibniz notation dy over dx, is equal to f prime of x times g of x minus f of x times g prime of x divided by g of x squared. And again, I try to get you guys to memorize the formula as well as the words, that math poetry thing, to get this thing drummed in. It's derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared. And these words are going to be much more advantageous for you guys. Okay? So we were working on a few of these problems. Now today, we're moving into section 3.2. This is called the chain rule. Now this chain rule is very straightforward, and it's the way you need to look at it. There's a lot of different ways to look at this particular chain rule, and the first way they look at it is this. You've got y equals to some function in terms of u, and you have u is equal to some function in terms of x, let's say. Then, if you want to take dy, the derivative of y, with respect to that x, dx, that would be equal to, you would take the derivative of y, but that variable is in terms of u, times dy over du, times, then you take the derivative of the u function with respect to x. Now this is your Leibniz notation of the chain rule version of this guy. Now, and this is the traditional formula, and it'll come in handy on occasion, but what you really need to understand is this. If you really look at this and put it together, what you've got here is this. Y equals f of, in place of u, you've got g of x. Now, let me explain. What you have here is a composition of functions. You got one function chunked into the variable of another function. So, and the way you need to look at this is outsides and insides. F is on the outside, g of x is on the inside. You've got this outside-inside composition of functions going on here. And we want to take derivative of this guy. So another way of looking at it, besides this Leibniz notation, is this. Dy over dx would be equal to f prime of g of x times g prime of x. That's the formula. But again, the way I like to look at this stuff, because it's going to become much more advantageous later on, is not just memorizing the formula, but memorizing the words of what you're supposed to do. So in terms of a chain rule, the derivative, this y prime would be equal to, the words are, you take the derivative of the outside, inside stays the same. Then you multiply it times the derivative of the inside. That's the chain rule. It's the derivative of the outside, inside stays the same, times the derivative of the inside. This is the way you look at the chain rule. So let me give you an example of that. So, if I give you this, y is equal to 3x squared plus 17x minus 2 raised to the 8th power. You stop, pause, and hesitate, and tell me what you see. I see this 3x squared plus 17x minus 2 on the inside, and the whole thing is raised to the 8th power, so that 8th power is on the outside. So that's the way you got to look at this stuff, insides and outsides. So my derivative, y prime, would be equal to, you take the derivative of the outside. That outside is that classic power. This is called the general power rule. You take your power to take a derivative, and you stick him out front. That'll be 8 times, remember, the inside stays the same, so just recopy it, 3x squared plus 17x minus 2, raised to the, subtract 1, 7th power. So that's the derivative of the outside. The inside stayed the same. Then you do times the derivative of the inside. The inside is this 3x squared plus 17x minus 2. What's the derivative of that guy? 6x plus 17. Derivative of the outside, inside stayed the same, times derivative of the inside. That is the chain rule. Does that make sense? And so, if you want a general formula for this, because most of the problems at this point are going to look like this guy, but don't worry, then we're going to add more functions to this stuff as we go through our textbook here. But this general power rule is this. And the general power rule, which is this chain rule version of this guy, is if I have y is equal to some function f of x raised to an n power, the derivative y prime, or if you want to, dy over dx, would be equal to the derivative outside. What I did was I took the n down front, the function f of x stayed the same on the inside, raised to the n minus 1, then I multiplied times f prime of x. That's basically the formula here, the general power rule. Okay? But you know where we're going with this stuff. So let me just kind of go ahead and give you a real clue of what's going on here. So, here we go. They're going to give you problems like this. Y is equal to 3x squared plus 7 divided by 5x minus 2 raised to the 9th power, let's say. And you look at this guy, and the way you need to look at it is this. What do you see? Pause, hesitate, and ask yourself, what do you see? I see y equals 3x squared plus 7 over 5x minus 2. I see a quotient. Numerator, denominator. I got a quotient. But it's being raised to the 9th power. That 9th power is on the outside. So honestly, this is a chain rule problem. The quotient is on the inside. They're going to start combining rules on you guys. The quotient's on the inside, but with that 9th power on the outside, the big rule is this is a chain rule problem. Okay? Chain rule. Derivative of the outside, inside stays the same time derivative of the inside. Those words are your commander. This is what you're going to follow. So to take derivative of this guy, y prime is going to be equal to the derivative of the outside. The 9 pops out front. The inside, 3x squared plus 7 divided by 5x minus 2 stays the same. Raised to the what? 8th power. But then I got to do times the derivative of the inside. And the derivative of the inside, I see a quotient. I see the 3x squared plus 7 divided by 5x minus 2. And so we go back and go, oh, what was the quotient rule? And again, you can memorize the words here. I mean, remember the formula, but the words are so much helpful. It's derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared. So that's what I'm going to do right here. I'm going to take, for the quotient rule, I'm going to take derivative of the top. What's derivative of 3x squared plus 7? 6x. Derivative of the top times the bottom, 5x minus 2, minus the top, 3x squared plus 7, times the derivative of the bottom. What's the derivative of 5x minus 2? 5, all over the bottom, 5x minus 2 squared. And I also mentioned to you guys last time, in these sections of chapter 3 that we're talking about here, I'm going to give you some directions that you've never heard of in a math class. Here's my directions. Take derivative, but don't clean them up. Why I don't want you to clean them up is because when I see this, I can see your algebra moves that you're making. I can see the derivative of the outside. Inside stayed the same. I can see the derivative of the inside, and I can see you using the quotient rule. So I know that you understand these rules and are applying them appropriately. Your biggest problem in this section is going to be the computer and the Hawk system. Now, the Hawk system is not great, but you got to type this stuff in, and it's this long, and you got to make sure that you put your parentheses in the right spot and stuff like that. So just be careful in typing it in. But you can clean it up if you want to, and that's fine on the Hawk system. That's absolutely fine. It'll look kind of right. But if you don't clean it up, and if you decide to type it in like this, and if as long as it's right and all the parentheses right spot, yeah, you'll give you credit for that too. You do not have to clean it up on the computer system at all. So you can leave it like this, but you just got to be meticulous in terms of typing it in. That's just going to be a pain, but this is the nature of the beast. As we go through calculus, the functions that we're going to be analyzing are going to be harder and harder and harder. Okay? So, let's go to our notes here. Where are my notes here? There we go. And last time we didn't get to one problem that I wanted to talk about, so it's a good problem to start with here from our notes. But it's a problem that you should not be real surprised about. Look at the question. Find the equation of the tangent line to the graph of f of x equals x to the fifth minus 5 times x cubed minus x minus 1 at the point 0, 5. Well, what a surprise. Those same directions that we had on our last test are going to be on this test as well, except for one thing. The functions are going to be a lot harder, okay? And then again, what's the question here? The question is very simply, find the equation of the tangent line. Anytime you hear the words find the equation of a line, what are you going to use? Point slope. We know how to start this problem. Point slope. It's a formula. Y minus y1 equals m times x minus x1. You've got to have two things to be able to use the point slope formula equation of a line. You've got to have a point, and there it is right there, 0, 5. They gave that one to you. And you got to have a slope. And you guys have been programmed personally by me. When you hear the word slope of the tangent line, what are you going to do? Take derivative. And then plug in your x coordinate, because it's got to be a number. So, my function f of x is equal to x to the fifth minus 5 times x cubed minus x minus 1. So my derivative, pause, hesitate, and tell me what rule you're going to use. If I x to the fifth minus 5 times x cubed minus x minus 1, well, that times in the middle tells me this is a product rule. What's my product rule? Derivative the first times the second plus the first times derivative the second. Derivative the first. What's derivative of x to the fifth minus 5? 5x to the fourth. Derivative the first times the second, x cubed minus x minus 1, plus the first, x to the fifth minus 5, times the derivative of the second. What's derivative of x cubed minus x minus 1? What derivative of x cubed is 3x squared, minus derivative of x is 1, and derivative of minus 1 is 0. There is my product. That is my derivative, product rule. Does that make sense? Now, this is the derivative. What we really want is the slope of the tangent line, which is the derivative evaluated at your x-coordinate. And the x-coordinate in this problem is 0. Okay? So, here we go. I'm going to plug 0 into this thing. This gives me 5 times 0 to the fourth times 0 cubed minus 0 minus 1 plus 0 to the fifth minus 5 times 3 times 0 squared minus 1. When I clean this up, 0 to the fourth is 0 times 5 is 0. 0 cubed is 0 times minus 0 is 0, minus 1 is negative 1. Plus 0 to the fifth is 0, minus 5 would be minus 5. And 0 squared is 0 times 3 is 0, minus 1 is minus 1. So cleaning this up, this will be 0 minus 1 is a 0. Negative 5 times negative 1 is plus 5. That gives me 5. My slope of my tangent line is equal to 5. Does that make sense? Now, I'm going to go and use my point slope formula for this stuff. So let's do that. So plugging it in, y minus the y coordinate, 5, is equal to the slope of the tangent line, which is 5, times x minus my x coordinate is 0. And there's my answer. But honestly, the point slope formula, even though it's the most important equation of a line, it's not the prettiest. So we usually have to solve for y. Question? Yeah.
Did we need to do all of that? Wasn't the point already given? Didn't we know that it was going to come out to be 5? Or am I
No. You're just, don't be confused. The y coordinate is 5. But the slope, you didn't know what it was until you took derivative. It just so happens to also be 5. That's a rare thing.
Okay.
These are two, just because that number's 5 doesn't mean this number's gonna ever be 5. It just happens to chunk out to be 5. But it's whatever you calculate what it is, it goes here, and then we'll go solve for y. So this gives you y minus 5 equals 5, x minus 0 is x. I'm gonna add 5 to both sides. I get y equals 5x plus 5. That's the equation of my tangent line of this function at the point 0, 5. And please, you're right, it just so happens to be 5, but no, we didn't know that. That's the y coordinate. This is a different kind of 5. That's the slope of the tangent line, and that came from the derivative and evaluating it at plugging in that x is 0. Okay? So, let's take a look at section 3.2 and talk about this chain rule. But you know, like I said, I'm setting you guys up. We're going to be using a lot of combination of these rules. You're going to have product rules with inside chain, quotient rules with inside chain rules. So all this stuff, that's why these words are going to be so important as we expand and make these functions much more difficult. Okay? So, we're focusing on the chain rule. And the way you need to think about the chain rule is inside, outside. You got a function on the inside, and you got something going on the outside. Inside, outside is a composition of functions. So, this first part here under our learn mode is the chain rule states that if y equals f of u and u equals g of x, then dy over dx is going to be equal to, you take the derivative of this guy, that would be equal to dy with respect to u, because that variable is in terms of u, then you multiply that times, this guy's your u variable, take derivative of u with respect to the x variable. Now what you're supposed to see on this thing is, as a product, the du's end up canceling and you get this dy over dx. Well, that's right, that's the main idea behind this stuff, but what you got here is you got one function in terms of u, and then you got another function u in terms of a different variable x. So you're really going to be taking this guy and plugging him into here, and it's got this. This is the derivative of the outside times this is the derivative of the inside. That's really what's going on. All right, but if you look at the from the viewpoint of composition of functions, and again we got this y equals f of g of x, then this chain rule states that the derivative is going to be f prime, take derivative of the outside, the inside g of x stays the same, times g prime of x. Okay? And again, the words makes all the difference in the world. It's derivative of the outside, inside stays the same, times derivative of the inside. So I'm going to put that right here. You take derivative of the outside, inside stays same, then you multiply times the derivative of the inside. And again, those are these words that I'm going to continue to beat up so you can see it within the formula. F is on the outside, g of x is on the inside. Derivative of f, derivative of the outside, the inside g of x stayed the same, times derivative of the inside of g prime of x. Now in general, and this is like in our general power rule aspect of this thing, if you look at the function's composition as y equals g of x raised to the n power, okay? The g of x on the inside, n power is on the outside, that will give you n times g of x raised to the n minus 1, derivative of the outside, inside stayed the same, times g prime of x, the derivative of the inside. And again, they will also make this little connection that under the assumption that f of g of x exists and g prime exists, same idea here, under the assumption that g of x exists and g prime also exists. So, I mean, the parts have to exist to put the whole darn thing together. Okay. Now, in terms of this general power rule, they're trying to describe exactly what you're doing to this thing, and so you've got this function y equals g of x to the n. So the first thing you do is you apply the power rule to this g of x to the n. And what I mean by the power rule is this. The n pops out front, the g of x stays the same, and then you got the n minus 1. And then you multiply by the derivative of g of x, which is the derivative of the inside. So they are hitting you around these words. Derivative of the outside, inside stays the same, times the derivative of the inside. So, let's do an example. This is one from your www.hawkstv.com example. And again, just to remind you guys that this is all on our Hawk system. They got a special place that you can go and watch examples. They do an example very similar to this, but it's different. So we can do this example ourselves. So find the derivative of f of x is equal to 2x to the negative 2 plus 5x minus 3 raised to the 3/2 power. They were nice enough to go ahead and clean this guy up. They usually don't give me a negative exponent. They usually put it on the bottom, and I have to go put it back to the top. So there it is. But what do you see in this problem? I see 2x to the negative 2 plus 5x minus 3 on the inside, and I see on the outside this 3/2 power. So my derivative, this is a chain rule problem, is going to be the derivative of the outside, so the 3/2 pops out front. The inside, 2x to the negative 2 plus 5x minus 3 stays the same, raised to the what? You've got to subtract 1 from that power. And that's what, honestly, where most people will screw this stuff up. They're doing it so quickly, they'll make careless errors. What's 3/2 minus 1? 1/2. Okay, derivative of the outside, inside stays the same. Then you got to do times the derivative of the inside. Derivative of 2x to the negative 2 is going to be negative 4x, subtract 1, negative 3, plus derivative of 5x is 5, and derivative of minus 3 is 0. And that's my derivative. Does that make sense? So, how bad can they make this stuff? Well, not bad, but it's that wording that they're going to throw at you and stuff. So, take a look at this guy right here. A manufacturer has determined the weekly profit from the sale of X items is given by, and they gave me the profit equation. P of X equals negative X squared plus 280X minus $4,000. It is estimated that after T days in any week, X is equal to 0.5 T squared plus 5T items will have been produced. Here's the question. Find the rate of change of the profit with respect to time at the end of 4 days. What are they looking for? Because we got multiple variables going on here. So I've got profit based upon X, the number of units I produce. But I also have X, the number of items that I produce, based upon T, the number of days that I have been working on this stuff. So we got multiple variables here. What they're after here is this. Find the rate of change. What does rate of change mean to you? Okay, good, you've been programmed. Derivative, all right, of profit. So I'm looking for dP, the derivative of profit, with respect to time over dt. That's what I'm looking for. dP over dt. The rate of change of profit with respect to time. But profit basically is in terms of this function x. So to get this dP over dt, and I take derivative of profit, this equation, I'm going to get dP over dx. But then to be able to get it in terms of time, I'm going to take my x equation and take derivative of x with respect to time. So I'm using the old Leibniz notation to be able to get this dP over dt. dP over dt is equal to the derivative of p with respect to x times derivative of x with respect to t. So this dx is end up canceling and you get the dP over dt, what we're after, the rate of change of profit with respect to time. So this dP over dt would be equal to, here we go, what is derivative of profit with respect to x? Here is my profit equation. What is the derivative of that guy? It's negative x squared plus 280x minus 4,000. What is the derivative of this guy with respect to x? Because this is the variable x. What do I get? Negative 2x plus 280. That's the derivative of negative x squared plus 280x minus 4,000. Times, I'm going to take derivative of x with respect to t. Well, x is equal to 0.5 t squared plus 5t. What's the derivative of that guy? Well, derivative of 0.5 t squared. Well, 2 times 0.5, 2 times a half is 1 t plus, what's the derivative of 5t? 5. And I'm just trying to show you, I'm literally just taking the derivative of each part and multiplying them together. Derivative of 0.5 t squared is t, because 0.5 is a half. A half t squared, 2 times a half is 1 t, subtract 1 to the first. But wait a minute, we're not done yet. We gotta find this rate of change with profit with respect to time at the end of 4 days. When time equals 4. But when time equals 4, x would end up being equal to what? 0.5 times 4 squared plus 5 times 4. Oh, it's time for the handy dandy calculator here. I don't think I need a calculator for this, but I'm going to do it for a calculator just to make sure I don't screw it up. So here it is. 4 squared is 16 times 0.5. Half of 16 is 8. 5 times 4 is 20. 20 plus 8 is 28. But you never know. I screwed this stuff up, so we do have calculators. 0.5 times 4 squared. Oops, wrong button there. 4 squared plus 5 times 4. Yep, 28. Beautiful math. It's only one answer. We both got it, so I feel better confident about this. So now, what I'm going to do here is I'm going to plug in for t, 4, but when I plug in t into x, when I see an x, I'm going to plug in 28. So to get this dp over dt, when t was equal to 4, basically I'm going to plug in t is 4, and when t is 4, that also makes x equal to 28. You get this. Negative 2 times 28 plus 280 times t was 4 plus 5. So for x, I plugged in 28, and for t, I plugged in 4, and I'm going to go put that on the old calculator here. So I got parentheses, negative 2 times 28 plus 280 times 4 plus 5. And I end up getting 2016. But one thing, it's a word problem. And being a word problem, I got to have units. This is why we like the Leibniz notation. The notation will tell me what the units are. We took the derivative of profit with respect to time. What's profit measured in? Dollars, American money, dollars, okay. What is time measured in? Days. And every time you take a derivative, it's a per, and we put a little slash for per days. So the actual answer is $2,016 per day. That's what's going on. So let me make sure you guys understand in terms of this scenario. They gave me, we worked it out, we have a profit equation based upon the number of units we produced. We also have the number of units we produced based upon the days out of the week, okay? So, after 4 days of production, our company is making a profit of $2,016 per day. Does that make sense? This is the profit that we're making. It's the rate of change of profit with respect to time. All right? Let's try a few more of these problems. Try this one here. Y equals 4x squared plus 9x minus 3 cubed. Take derivative of it. That's all it says. So, y prime or dy over dx, whatever notation you want to use, just make sure you label it. Y prime equals dy over dx equals this. What do I see? Pause, hesitate. I see 4x squared plus 9x minus 3 on the inside, raised to the third power on the outside. That's chain rule. Derivative the outside, inside stays the same, time derivative the inside. That's going to give me 3, derivative the outside. Inside stays the same, 4x squared plus 9x minus 3, raised to the second power, times the derivative of the inside. Derivative of 4x squared is 8x, plus derivative of 9x is 9, derivative of minus 3 is 0. There's my derivative. But very quickly in this class, you are going to discover John's fundamental theorem of calculus. John's fundamental theorem of calculus is very simple. It is better to do your algebra before your calculus than afterwards. Clean it up first. Take a look at this problem here. I got y equals the cube root of 5x cubed minus 4. I don't do cube roots. You've got to clean them up first before you take its derivative. So, cube root is a 1/3 power. So this is 5x cubed minus 4 raised to the 1/3 power. Now, as you view it like this, I've got this function on the inside and that 1/3 power on the outside. That screams chain rule. Chain rule. So my y prime, dy over dx for those Leibniz fans out there, is equal to derivative of the outside. The 1/3 pops out front, The inside 5x cubed minus 4 stays the same. Raised to the y. What is 1/3 minus 1? Very good. Negative 2/3 times the derivative of the inside. Well, the derivative of 5x cubed is 15x squared. Derivative minus 4 is 0. So there's my answer. And again, I'm not cleaning this stuff up. If I was going to clean it up, all right, if I decide to clean it up. Now, a problem like this is a great multiple choice kind of question. And you know, in multiple choice questions, we're going to have to polish that answer so you can get a nice little lineup of A, B, C, D, E and try to pick it out from it. Let's see if we can clean this guy up. This is how I would clean it up. Put my constants together. What's 1/3 of 15? 5. 15 divided by 3 is 5. So y prime would be equal to 5x squared. It just pretty much canceling that part there. And then the negative exponent takes the whole function and goes where? On the bottom. And you get 5x cubed minus 4, and you raise them to the positive 2/3 power. That's what it would look like if you cleaned it up. But on my test, there's going to be a huge section, especially under the free response, where I'm going to say, hey, take rid of this stuff and don't clean it up. And I actually want to see the answer just like this because I want to see the rules in action. Does that make sense? But on multiple choice problems, expect something like this. So you've got to have the ability to clean this stuff up. So let's take a look at this guy. So how bad can they get? So this problem here. Now I warned you about this. Now we're going to start doing these combo rules. First thing is I want to clean it up. G of x is equal to x squared divided by the cube root of x squared plus 6. Cleaning this guy up, this is equal to x squared divided by parentheses x squared plus 6 to the 1/3 power. And I'm telling you guys right now, the trick of being able to master this material is just don't jump in with both feet. Take 2 seconds, pause, hesitate, and look at it and tell me what you see. I see garbage divided by garbage. Sorry, that's what I see. Something on top, something on bottom. That means it's a quotient, right? Yeah, I see some chain rule action here too, but we're talking about combo rules here. I got to figure out who's in charge. What's the big picture? The big picture is this long division right here. That means it's a quotient. It means I got to use the quotient rule. So back to my rules again. What's quotient rule? Derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom squared. This answer is going to be about yay long. Here we go. So g prime of x. The big rule is a quotient rule. So I'm going to use the quotient rule. Derivative of the top. What's derivative of x squared? 2x. Times the bottom. Just recopy. X squared plus 6 to the 1/3 power. Minus the top. Just recopy it. X squared times the derivative of the bottom. What do I see in the bottom? I see x squared plus 6 to the 1/3 power. That's a chain rule. Inside, outside. Chain rule says you take the derivative of the outside, so the 1/3 pops out front. The inside, x squared plus 6 stays the same. Raised to the subtract 1, negative 2/3, times the derivative of the inside. Derivative of x squared is 2x, and derivative plus 6 is 0. So understand, and I'm going to underline these for your benefit. This was derivative of the top times the bottom minus the top times the derivative of the bottom with the chain rule all over the bottom, x squared plus 6 to the 1/3 power squared. It's nasty looking, but that's my answer. Question? Yeah. Okay, so, you first off, you see this a quotient. The big picture is this thing's a quotient, make long division. So, quotient rule, derivative of the top times the bottom minus the top times derivative of the bottom, all of the bottom squared. The 2x is the derivative of the top. Derivative of x squared is 2x. Derivative of the top times the bottom. I just took this bottom and recopied it. X squared plus 6 to 1/3 power. Minus the top, I just recopied it. And I'll put little parentheses around it for you. Times the derivative of the bottom. Now, when I took derivative of the bottom, I had to pause and go, hey, that's a chain rule. Chain rule is derivative of the outside, so the 1/3 popped out front. The inside, x squared plus 6 stays the same. Then I had to subtract 1. 1/3 minus 1 is negative 2/3. That's a negative right there. Okay? Chain rule. Derivative of the outside, inside stays the same, times the derivative of the inside. That 2x came from the derivative of that x squared inside. All over the bottom, just x squared plus 6 to the 1/3 power, the bottom squared. And that's the answer. Now, in terms of cleaning it up, there's not much I could, I mean, I could clean this up slightly. And I would do this, if I decided to clean it up, and, you know, a little bit of cleanup on the Hawks may be helpful, because this thing's gonna be a pain to type in. I'm not arguing that point. So I would just, but I'm gonna do very minimal cleaning up. This would be 2x times x squared plus 6 to the 1/3 power, minus, I can group together stuff, that 2x, well, first off, the 2 times the 1/3 makes it 2/3, put my constants together. The x squared times the x makes it x cubed, and then I still got this x squared plus 6 to the negative 2/3 power there, okay? All over the bottom, x squared plus 6. Now, a power raised to a power. Where's my exponent rules here? Power to a power, what do I do with the powers? Multiply. 1/3 times 2 is 2/3. And that's the worst, I mean, that's the best I would clean this thing up. Even if I was doing a multiple choice test, I would have probably left it just like that. Does that make sense?
Question?
Yeah.
So for the sake of consistency,
Yeah.
before you cleaned it up on the denominator,
Yeah.
could we have just enter the one on the top and then just to the
To the-
second power?
One on the top,
Right, so that side,
this side, and then divided by, and you could raise this, you know, the bottom, you could, I mean, in Hawks, you can type it in exactly like this, and you'll get it right. I mean, that's absolutely fine.
right, no, but what I mean is, the part on the top that starts at 1/3, the second part.
Yeah, yeah.
That part, if we would have taken that whole thing, put it at the bottom, and then to the second power, would that have been okay?
Yeah, that's gonna be a little bit tougher to type in. I'd leave it as negative exponent, because here's the thing, you can't take this guy and shovel him completely down here. The reason why, it's a minus. You can only do strict multiplication division, can you actually start moving stuff around, tops and bottoms. Because of this minus, he's only gonna be on the bottom of this, so you're gonna make this guy an individual little fraction and put him on the bottom of that. You can't move him down here because of that minus here, because there's 2 terms here. So, no, don't do that, that would actually make it wrong. Does that make sense? Okay. So that's why I left it like this. I mean, I left him with a negative exponent, that's good. Because if I made him, he's only gonna become the denominator of the 2x cubed over 3. He's gonna go down there where the 3's at, but not way down here. Take a look at the next guy. Y equals 2x plus 7 cubed times 3x plus 1 to the negative 4th power. Pause, hesitate, and tell me what you see. And if you don't know, write, say it out loud. Well, officially, not on a test, you have to say it in your head, but speak it out loud. What do you hear? It is y equals 2x plus 7 cubed times 3x plus 1 to the negative 4th. That times in the middle tells me, what's the big picture on this one? It's a product. So I'm going to use the product rule. Yeah, I see the little chain rule guys here, but the big picture is a product. It's this function times this function. So I'm going to use the product rule. My product rule is, once again, derivative of the first times the second plus the first times derivative of the second. So to take derivative of the first guy, I got to use the chain rule on that guy. Chain rule, derivative of the outside, inside stays the same times derivative of the inside. That 3 is going to pop out front. The inside 2x plus 7 stays the same, raised to the subtract 1, 2. Derivative of the outside, inside stays the same times derivative of the inside, 2. And I'm going to put a little brackets around it because I'm trying to separate them for your benefit. That is the derivative of the first guy. The big picture is, it's a product rule. You take derivative of the first guy, and then you multiply it times the second guy. So you just recopy 3x plus 1 to the negative 4th power. Okay? Then you put plus, you copy the first guy, 2x plus 7 cubed. Then I'm going to put times, I'm going to put a little bracket here because I'm trying to separate this so you can see the parts here. The derivative of the second. The derivative of the second is 3x plus 1 to the negative 4th power. That's chain rule once again. Chain rule. Derivative of the outside, the negative 4 pops out front. The inside 3x plus 1 stays the same. Raised to the what? Got to subtract 1. Negative 5 times the derivative of the inside. Derivative of 3x plus 1 is 3. And there's my answer. Not cleaned up, of course, but that is my answer. The derivative of the first term times the second plus the first term times the derivative of the second. And question? Yeah. Then I would have used the quotient rule on it. That would be fine too. Would it look any better? No. Okay. It's still gonna look awful. I don't care what you do with the darn thing. But you're right. I mean, so you could have cleaned it up. Absolutely 100% right. If you want to take that negative exponent and put it on the bottom, you could have used the quotient rule on this thing. And then drill the top times the bottom minus the top, try to drill the bottom, all of the bottom squared. And at the end of the day, even though my algebra would look a bit different from your algebra, if you both cleaned it up to the utmost degree, it ended up being the exact same function. Take a look at the next guy here. F of t equals t squared plus t plus 1 divided by the square root of t to the fourth minus 1. Well, the way it's written, this is t squared plus t plus 1. I don't do square roots. The square root is a half a power. So this is t to the fourth minus 1 to the 1/2 power. Again, the trick to doing this material is that 2 seconds. It takes to pause, hesitate, and look at it, and tell me what the big picture is. What's the big picture in this problem? Quotient. This is a big division problem, a big little line down the middle. I know the little parts have different parts to them, but the big picture is this is a quotient rule. Drill the top times the bottom minus the top, trying to drill the bottom, all of the bottom squared. So here we go. Drill the top. Drill of t squared plus t plus 1 is 2t plus 1. Drill of t squared is 2t. Drill of t is 1. Drill of 1 is 0. Drill the top times the bottom, t to the fourth minus 1 to the 1/2 power, minus the top, just recopy it, t squared plus t minus 1, times, and the derivative of the bottom. To derive the bottom, I gotta use the chain rule because it's t to the fourth minus 1 to that 1/2 power, inside, outside. Okay, so chain rule. Take derivative of the outside, the 1/2 pops out front, the inside, t to the fourth minus 1 stays the same, raised to the what? Subtract 1, negative 1/2, times the derivative of the inside. Derivative of t to the fourth is 4t cubed, derivative of minus 1 is 0. So all of that is the derivative of the bottom. All over the bottom, t to the fourth minus 1 to the 1/2 power, the bottom squared. That is my answer. Now, when I'm talking about doing the Hawk system here, and I have to type this kind of an answer into it, and this is a pain. I can do a little subtle cleaning up, but I'm not going to do much. There's going to be lots of typing to do on these problems. You can't avoid that. But if I was going to clean this up, the only thing that I really would clean up would be something like, I would put my constants together, and this power to a power, I would clean that up. So here's my answer here. F prime of t would be, I would write it like this, 2t minus 1, 2t plus 1. 2t plus 1 times t to the fourth minus 1 to the 1/2 power minus, and I will put my constants together. What is a 1/2 of 4? 2, I can stick him out front here. 2 times the t squared plus t minus 1 times, and I could put the t cubed up here too, t cubed right there, and the times the t to the fourth minus 1 to the negative 1/2 power. And that's best I would do it to them. I would basically put the half times the 4t cubed and make them 2t cubed out front of this whole term here. But then the other thing I would do is this, divided by power to a power you multiply. What's a half times 2? 1. This is pretty much square root of square, which cancels. So you're just going to be left with t to the fourth minus 1. That's the best I would do to it because it's still going to be nasty in terms of typing it in. All right. Last one for the day here. Take a look at this guy. G of t is equal to 5t plus 4 divided by t squared minus 3 raised to the fourth power. Pause, hesitate, and tell me what you see. What's the big picture? Chain rule. That fourth power on the outside of this thing. Yeah, I see that quotient too, but the big picture is the whole thing's being raised to the fourth power. This is a chain rule problem. So, the derivative is going to be equal to this. Chain rule. Derivative the outside, inside stays the same time derivative the inside. Noticing how much I'm using the words. I'm not using n times f of x raised to the n minus 1 times f. I'm not using the formulas. I'm not using like quotient rule, f prime times g minus f times g prime over g squared. You're going to get confused by all the g's and g primes and all this stuff. Noticing the words is going to help you out so much more. Chain rule. Derivative the outside. That 4 is gonna pop out front, the inside, 5t plus 4 stays the same over the t squared minus 3. 4 pops out front, the inside stays the same, raised to the third power. Don't forget to subtract 1 off this guy. Derivative of the outside, inside stays the same, times the derivative of the inside. Now on the inside, what do you see? Quotient. Derivative of the top times the bottom minus the top times derivative of the bottom. Let's go that again. Derivative of the top times the bottom minus the top times derivative of the bottom all over the bottom square. Derivative of the top. What's derivative of 5t plus 4? 5, derivative of the top times the bottom, t squared minus 3, minus the top, 5t plus 4, times derivative of the bottom. What's derivative of t squared minus 3? 2t, all over the bottom, t squared minus 3 squared, the bottom squared. And there is my quotient rule in action. Does that make sense? Now, you need to do a lot of practicing on this stuff. And so, and again, you can clean this up by distributing the 5 throughout. You have to distribute the 2t and the negative. Don't forget the negative is going to change your signs. So watch your algebra if you decide to clean this up. But one other thing I want to, yes, question. Yes, ma'am. Yes, one? No, because it's in the parentheses. I left that negative out front. All I did was take these two, this is all being multiplied, and I multiplied a half times a 4t cubed and made them 2t cubed out front, and I left that negative out front. I didn't distribute the negative. If I wanted to get rid of all these parentheses, I would now distribute this thing throughout, and, well, I still got this mess over here. It's not going to clean up very nicely, okay? Yeah?
No, but like right before the one time t squared minus 1, you put t squared plus t minus
2 to the 4,
to the left.
yeah?
There shouldn't be t plus 1 instead of t minus 1.
T plus 1, hold on. Yeah, that's me. Yeah, this one should be a T plus 1 as well. That is me being a typo here, because this is T plus 1s, isn't it? Oh, thank you for noticing that. One last thing, that would be a plus. I didn't copy it down correctly when I'm typing the inside. One last thing. If you go to your Hawks thing here, and I put the thing up here, in terms of, go to Canvas and then log in through your Hawks system here, it says this. Your quiz 4 is due on Saturday. 3.1, the rest of that's due on Sunday, but I moved 3.2 to be due, I think, by next Thursday. I want to give you some more time because you're doing these combo rules here, so I pushed back 3.2. However, quiz 4 is only on product rules and quotient rules. It's only on 3.1. It's not on the stuff we covered today, so I'm trying to buy you some more time on this. So I pushed back just by a few days. So in the middle, I think it's due on like the 21st or something like that. 3.2, the lessons are due then. All right, so study hard, go certify, and make A's. There you go.